Crunch Math. Today we're going to be going over the advanced math section of the SAT, including nonlinear functions, nonlinear equations in one variable, and systems of equations in two variables, and equivalent expressions. We're going to go over around 6 practice problems with these, which I view as the harder end of the stick for them, and also decided by College Board. These are the questions you're going to probably see and encounter on the SAT. Before we do that, though, we need to understand some key concepts involving nonlinear functions. So let's get into that right now. So here we're going to have our blank sheet. First, just know the quadratic equation, where you have ax squared plus bx plus c. Now, A, B, and C, these are all going to just be constants. That's all they are, but we're going to need them in order to show some different equations. But this is just our basic quadratic formula. Now, we can derive a few equations. First, you can see this in a vertex form. The vertex being where the minimum or maximum of your quadratic function, which can be seen either right here, or right here. But let's write this equation. This equation is written as y, or whatever our function is, equals a times x minus h, and then you square this, plus k. Now, h and k, what do these mean? These are going to both be some sort of number, but h is going to be the x, with the x value of our vertex is, and k is going to be the y value of this vertex. And these can become helpful in different problems involving the vertex. Now, another one involving the vertex is we can find out what this h value is, or this x value is, using the quadratic formula again, as it's going to be equal to negative b over 2a. And this is the next one in order to find the x-intercept, or not the intercept, the x-coordinate of our vertex. Now we're going to move into the next one for these. The next one for this, using this quadratic equation still, let's write it in red, is going to be the discriminant. So let's write it right here in red. So the discriminant, when you put the quadratic equation in a certain form in order to factor it, sometimes you'll see it as negative b plus minus square root b squared minus 4ac divided by 2a. Now, in this, we can find a discriminant. This discriminant is going to be this part I circle in green, or box in green. It's going to be this b squared minus 4ac. And let's just call this d. We'll just write it right here as d. That's our discriminant, b squared minus 4ac. If the discriminant equals 0, when we do a little math, that means we'll only have one real solution. If the discriminant is greater than 0, that means we're going to have two real solutions. And if the discriminant is less than 0, that means we're going to have 0 real solutions. But what does this real solutions mean? So let's write it in blue or in red here. So let's say we have our graph. It's going to have one real solution if the graph comes up and touches the x-axis only once, which is going to be at the vertex. That's another important. If it has one real solution, it crosses the x-axis where the vertex is. If it has two real solutions, then it's going to cross the x-axis twice. And if it has 0 real solutions, it's either going to be above or below the x-axis, never touching it. And that's what the discriminant is. So sometimes you'll see a problem that says this equation has one real solution. What you're going to go to is your first identify your a values grouping with the x squared, your b values grouping with the x, and the c values grouping with none of the x values, and then you can apply the discriminant formula. So now let's actually go into another page to go over some key concepts. Keeping with the quadratic function, we saw that first equation of factoring of negative b plus minus square root b squared minus 4ac divided by 2a. That's the first way of factoring. But we have multiple ways of factoring. The other one you can do more intuitively. So let's say you have x squared minus 4x, or sorry, let's say you have, let's say I'm just trying to think of an example, but let's say you have negative x squared minus 3x plus 2. We can factor this. You don't have to go through the long way of doing the negative b squared, yada yada yada. You can do it more intuitively. So let's split up this x squared. We can split this up between x and x. We can split up this 2 in either one of two ways. You can split between positive 2 and positive 1, or you can split up with negative 2 and negative 1. When you break down this c value right here, when you break it down to factor, the factors should both, when multiplied together, should both equal a c value. So if it's, let's say, 6, then you can divide it between 6 and 1, negative 6 and 1, negative 2 and 3, and 3 and 2. You have a variety of computations, but you can figure it out intuitively. Then what you're going to do is, from this, you're just going to combine these to this x plus 2, or x minus 2, and this x plus 1, x minus 1. But we're going to see it's not going to be this 2 or 1. How does this work? So when you divide 2 and get its factors of negative 2 and negative 1, what you're going to do is you're going to multiply it with the one across. When you multiply with the ones across, you'll get two values. Let's just call capital A in this case, plus capital B. When you get these two values, this should equal your lowercase b value when you cross multiply them. But then to factor them, you're just going to group them based on what's directly across. So you're going to group them based like this and based like this, in which then you're going to get your values as x minus 2 and x minus 1. These values are going to tell us where the quadratic function crosses the x value. So that's just a really quick overview of factoring. It could be better explained, but we're trying to move through this relatively fast. Now let's move into another part of exponential equations. So let's say you have a function where you have y plus some, let's call it b, just for this case, times a to some x value. What are each of these things going to tell us? This b, when you see it written in certain forms like this, where you have the parentheses, the b is going to be your initial value. This is basically going to be when x is equal to 0. When x is equal to 0, your a value goes to 1, and which then you're going to have your y-intercepts. This b value is your y-intercept, but it's also, in word problems, it's going to be your initial value. A is going to be your rate. If it's above 1, then you have an increasing exponential function, as above 1 symbolizes something going over 100%. If below 1, you have a decreasing exponential value, and it's decreasing because below 1 means you're decreasing it by certain percentages. This x value is going to symbolize things like time, in which, let's say your initial value is 10, and it's increasing by a rate of 10%. If it's increasing by 10%, this a value is going to be 1.1, and every month, let's say, every month it increases by 1.1. This x value is going to symbolize each month. So if it's 2, then you're going to have 2 months there, and that's going to specify time. And you'll see that these equations, depending on how a looks, If it's greater than 1, it's going to look like this. But if it's less than 1, it's going to look more like this. It's going to look more like this. The x-axis, depending on when it's shifted, there's going to be an asymptote that's never, ever going to touch. All right. Now let's go over some other things. Let's go over things known as shifting the graph upwards, downwards, things like that. So let's have our vertex equation where we have just something like x squared plus 6. This is going to equal our y. So when we shift it, let's say we shift it upwards 1 unit, you're not going to add anything to this x right here. You're going to add it outside of that. So let's say you shift it up 1, you're just adding a 1 to it. But let's say you want to shift it down, you're just going to add -1, and you're just adding these. But let's say we want to move it to the left or to the right. What we're then going to do is we're going to have to add something to this x value right here. Let's say we want to shift it to the right once. We're going to do x minus 1 squared plus 6. This is going to shift it to the right 1. While x plus 1 squared is going to shift it to the left once. So when you subtract something from your x value, where x value is, that's going to shift it to the right. When you add something to it, it's going to shift it to the left. You just have to think opposite with this. This is basically it. Now we're going to go over one more thing. Let's say you have to get like fractions. Let's say you have 1 plus x squared plus 2 over x plus 1. You want to get a common denominator between these things. Well, what you're going to have to do is this equation right here doesn't this x plus 1, so you need to multiply its numerator by x plus 1. But the problem is this 2 over x plus 1 doesn't have an x squared. So you're going to multiply this numerator by x squared. So now let's multiply everything up. 1 times x plus x, because that's just that. And then plus 2 times x squared. So now you have this right here. And then your denominator is just going to be whatever your two denominators were before, and you're just going to multiply them by each other. So it's just going to be x squared times x plus 1. And that's how you do combining fractions. And it's going to be the same thing if you subtract them too. And that should be it for most of the teaching. Now let's move into some problems. Obviously, try and check out some other videos if some of these concepts still are confusing. We're trying to move through this fast, but obviously I want you guys to have some basics down involving the algebra. So let's get into some problems. All right. The first term of the sequence is 9. Each term after the first is 4 times the preceding term. If w represents the nth term of the sequence, which equation gives w in terms of n? Pause to go over this question, hopefully come to an answer. All right. What this is this is basically, even if you don't look at the answers, you should know this involves exponential functions. We're calling the y in this case w. And let's look at this. The first term, the initial term, is 9. So let's just put this right here. Then we need to find the rate. The rate, it says, is 4 times. So this is just 4 times. So you're just multiplying this 9, but let's put the parentheses to visualize it better. 9 times 4. Now, once you get to here, we still have to add this n. I may have to find some way to incorporate it, but just by looking at that, you should get a out and you should get b out. Now we want to get this n involved. Let's erase this. Let's look at this. It says it's 4 times the preceding term. We're calling n a term. So you would have to write n right here, but it has to be n the preceding term. Meaning you're subtracting 1 from it. Like this. The reason you're doing it is because it's not, each term after the first isn't 4 times the current term. It's not 4 to the nth. It's times the preceding term. So it's 4 to the nth minus 1 is how you have to view it. And you're going to get your answer as D. And if you're confused about this, you can check it. The first term is 9, meaning you're going to plug in n as 1. When you plug in n as 1, you have 1 minus 1, meaning this is going to be 4 to the 0, which is the same as 4 to the 1 times 9, and that will check out for the first term. So you can do checks like that. But that is going to be our answer. Now let's go on to the next one. Alright, in the xy plane, when the graph of function f, actually, I'm going to give you all seconds to read this question, go over it, and hopefully come to an answer, and then we can solve it for ourselves. Alright, let's go over this. What they're doing is we're given this equation, but then we're given a new function g of x, where they're shifting it up 6 units. Remember when we said shifting it either up or shifting it down? We're not going to add anything to these x values. We're actually going to add it outside of it, how we normally would. So this function g of x is just this whole thing plus 6. That's what this is, shifting it up. And then they give us a point 4b. So at some g, and this is now this is going to equal this. At some g of 4, g of 4 is an equal b. So what we're just going to do is we're going to plug into 4 into every single one of these x values. So let's look at x minus 1. If you plug in a 4 there, that's going to be 3 times x plus 3. If you plug in a 4, that's 7 times, if you plug into 4 into x minus 2, that's 2. So let's do this. You get 21 right here times 2. That's going to equal 42. You may be thinking you got your answer here, but remember that you have to shift it up 6 units. So don't forget your 6 right here. Bring it back here. You're just adding 6. And your answer is then going to be 48. This is why the lesson of learning how to shift things up and down and side to side matters. So you'll get problems like these that seem complicated, but they're actually really simple. They're really simple. And this goes back to our tips in the earlier video, the part 1. Remember, try and understand what you're looking at before you tackle it, because it's going to make it so much easier when you see things like shifting and g of x and f of x. Now let's go on to the next problem. Pause to look at it, and then we'll go over it. Alright, in the given system of equations, a is a constant. The graph of the equations in the given system intersect at one point. What is the value of x? Now, what do these two terms have in common? They have some y's in common. So let's set them equal to each other. So let's just move the 3x plus a up here. And you'll get something like this. So now let's just move everything to the other side. And when we do that, you're going to get 0 equals 2x squared minus 24x plus 64 minus a. So we have this equation right here. And when we look at the equation, they intersect the x-axis. or they intersect at one point. But when you combine the two equations together, you have a new quadratic formula. And when they intersect at one point, just view it as it crosses the x-axis at one point here. So we can actually use the discriminant formula. The b squared minus 4ac. Now our b squared is negative 24. So it's going to be negative 24 squared minus 4. Our a is 2. And our c is 64 minus a. So now we can get here. We can simplify this further. Let's first simplify the 4ac. This can be written as 8. Then it's just 8 times 64 minus a. So now let's just bring out our calculator. We're allowed to use a calculator, which is Desmos. 24 times 24. That is 576. And then negative 8 times 64 is negative 512. And then just minus 8a. Now we have this. When we have one solution or one point, our discriminant is going to be equal to 1. Or it's going to be equal to 0. So now we can just set this equal to 0. Let's combine 576 and negative 512. And what you'll get then is equaling 0. It's going to be 64 minus 8a. We can move this 8a to the other side, and you're going to get 8a equals 64. Divide each side by 8. And when you divide each side by 8, you'll get a equals 8. That's going to be our answer. This problem involved a discriminant and knowing factoring, knowing and how quadratics work, which is why getting the fundamentals down on quadratic is super important, because the fourth of this exam is simply just going to be knowing discriminant, factoring, and just applying it. That's all it is. But my tip for this is when you see these two equations, just find some way to combine them. And after that, you can just simplify from there. All right, let's go to our page. Let's go to the next one. In the xy plane, the graph of x squared minus 9 intersects line P at 1a and 5b, where a and b are constants. What is the slope of line P? I'll give you all a second to read, go over this, and get an answer. So, go do that. All right, hopefully after you paused it, you'll have gotten an answer. But now let's go over it. We see that we have some sort of line. We don't know if it's positive or negative, but let's just say it's something like this. For example, it can either be positive or negative, but this is a rough thing what we're looking at. Not exactly, it's not that we're close to exactly, but let's just say it looks something like this. We have 2 points, and we're looking for the slope. But what we can do with these 2 points is you can just figure out slope. It's change in y over change in x. But we need to figure out what a and b are. So what we're going to do is we're going to use our quadratic function, x squared minus 9. This is still a quadratic function. So let's plug in 1 into x. When you plug in 1 here, it's just 1 minus 9. This is going to tell us that a equals negative 8. Right? Now let's plug in 5. 5 squared is 25 minus 9. This is going to be our b value. 25 minus 9 is our b value, and that's just going to be 16. So b is going to equal 16. Now we can just figure out change in y or change in x. Our change in x, our final value is 5. Our initial value is going to be 1. So 5 minus 1 on the bottom, this is going to be equal to our change in x. Our change in y is going to be b minus a. B is our final, which is 16. And a is -8, which is our initial. So now we get this equation. And now we just need to simplify from here. Our bottom is just going to be 4. Our denominator is 4. Our numerator is 16 minus -8. This turns to positive. And it's 16 plus 8, which is 24. Then it's 24 over 4, which is just 6. Now this is an important question, as you need to both know how linear functions work and nonlinear functions work. What you're going to see, what this shows you is that different concepts are going to intertwine and intermingle. What you need to know for this is just know how functions work in general and understand their relation to linear functions with slope. And that's all this part was. Now we have 2 more questions. Let's go over this. I'm going to let y'all pause and read this question and come to an answer, then we'll go over it. Alright, after you paused it, hopefully got into an answer, let's go over this. Now this is going back to our earlier lesson of how to combine like terms. How we're going to do it, we need to make these numerators the same. How we're going to do it, this 2 over x minus 2 doesn't have an x plus 5. So we're going to multiply the numerator by x plus 5. We're not going to look at what it equals right now. Let's just focus on simplifying this half. And this 3 over x plus 5 doesn't have an x minus 2. So let's multiply this by x minus 2. So now let's combine all of this. X plus 5 times 2, so 2x plus 10. And then we have to add 3 times x minus 2, so 3x, and 3 times -2, which is just going to be 3x minus 6 over our denominator is just these 2 numerators multiplied by each other. Now, we can simplify the numerator. Let's combine the x terms. You have 2x, and you have 3x. So let's just combine it up here, and that's just going to be 5x. And then 10 minus 6 is just going to be plus 4. So our numerator is 5x plus 4. And this is equal to rx plus t. What this tells us now is we see that the ones involving x, the 5 relates to the r, where 5 is going to equal r. And then this 4 relates to t, where t is going to equal 4. So now we have our values just by first simplifying one half, not even looking at the second half of it. Once we simplify it down, we can just combine like terms and relate them, relating the x values and the ones without the x's. Now we figured out what r and t is, and now we can get to what it's asking. It's asking for r and t. And now we just have to multiply 5 times 4, which is just 20. And our answer is going to be C. That's all it was. This one, don't always take it as all at the front. Just try and simplify what you can first before you try looking for an answer. Simplification is probably the biggest tip I can give you on the SAT. Simplify it to a point where you can comprehend it and make it easy. These expressions, we're looking for the value of p. I'll give you all a second to go over this and hopefully come to an answer. Alright, after you pause and hopefully come to an answer, let's go over this. The first thing I immediately think of is simplification. I know it's repetitive, but let's simplify it. We can just distribute this 3, and we can distribute this negative 16x. Let's focus on this part first, though. You'll see it's 6x squared plus 3px plus 24. This negative 16x times p is just going to be negative 16px. And then negative 16x times 4 is just going to be negative 64x. Now, what we can do here is we can then just combine like terms. 6x squared plus 3px and negative 16px, that's just going to be negative 13px minus 64x plus 24. And we'll see that this is going to be equal to what we underline in red right here. Now, instead of rewriting it all, we can just see when you set this equal to this, the 24s are going to cancel out. And you're going to be left with negative 13px minus 64x is equal to negative 55. They all have x in common, so let's just cross out the x's. And what you're going to see now is you're going to see negative 155 equals negative 64 minus 13p. We're looking for what the value of p is. So what we're going to just do is we're going to add 64 to each side. So you cancel that out right here. When you add 64 to 155, let's use our calculator here. You're just going to get negative 91 is equal to negative 13p. Then right here, just simplification. Just divide each side by negative 13. You'll see that this one cancels out. And then you divide this by negative 13. You're going to see that p equals 7. And now we got our answer. And we can just have it here. This is less knowing how quadratics work. In a way, it actually does. Because you just need to know first distributing, and then you need to know the whole ax squared plus bx plus c, and you need to group the terms that equal to b in order to get your answer. But these were the hardest questions I could get in this section. We went over some lessons over everything, and we were able to apply them to questions. Hopefully, this was a quick guide, easy and comprehensive, in order to understand and get a good grasp on the advanced math. We hope that you understand nonlinear functions, particularly quadratics, but also exponentials, and also the equations that come with it, like the vertex equations, the discriminant equations, the x-coordinate of the vertex, and also understand how to find common denominators when you have things like variables. But that's going to be it from Crunch Math. We'll be going over the rest of the 2 sections in 2 more videos, and then we're going to go over the hardest problems. But that's it from us. Thank you for your time, and we hope that y'all will do well on y'all's SAT. Thank you.